Hello everyone. In this lecture of the Essential Calculus Problem series, I will solve this problem. Integral of cosine to the power of n x dx. And here n is an odd number. This odd number can be 3, 7, 5, 11 or etc. Let me take this number as, for example, 7. Cosine to the 7x dx. In such, we will use substitution here. For the odd numbers to the powers of cosine function, we always use substitution. Okay, substitution method. When do we use substitution method? But this part is actually important. If we have a function u and if its derivative is multiplied by dx in the integral, then we can use the substitution method. It does not matter how u appears here. It may be raised to a power such as u squared, u cubed, or u to the power of 5, etc. It may be inside a square. It may be square root of u or cube root of u, etc. And it may be in the denominator of a rational function such as 1 over u, 1 over u cubed, or etc. What truly matters here is that the derivative of that function is multiplied by dx. Now, for this function now, we know that the derivative of cosine x is minus sine x and derivative of sine x is cosine x. We know that derivative of sine x is cosine x. And we know that if we have an even power of cosine x, we can write it in terms of sine x. If we have cosine square of x, it can be written as 1 minus sine square of x. If we have cosine to the power of 4x, it is equal to cosine square of x square, or then we can write it 1 minus sine square of x square. So, what we need here to do is that I will split cosine to the power of 7x into two parts, and I will write it as cosine to the power of 6x times cosine x dx. And if we can write this part using sine x, then we can use substitution method. And cosine to the 6th power of x is equal to cosine square of cube of cosine square of x. And cosine square of x is equal to 1 minus sine square of x. So this integral can be written as 1 minus sine square of x cube multiplied by cosine x dx. Now, we can use substitution here because we know that the derivative of sine x is actually cosine x. So let me say sine x is equal to u, then cosine x dx will be equal to du. And this means that this integral is 1 minus u squared cube times, since we rewrite sine x as u and we will rewrite cosine x dx as du, then the integral becomes 1 minus u squared cube du. Okay. This is written, okay. We know that a minus b cube is equal to a cube minus 3 times a square b plus 3 times a b square minus b cubed. Here we have 1 for a and u square for b. Then 1 minus u square cube is equal to 1 minus 3 times 1 times u square plus 3 times 1 times u square u to the power of 4 minus cube of u square u to the power of 6. Okay, now the integral is 1 minus 3 times u square plus 3 times u to the power of 4 minus u to the power of 6 du. And I will break down the integral into 4 different parts. The integral is du minus 3 times u to the u square du plus 3 times u to the power of 4 du minus u to the power of 6 times du. Now remember, if we have a function x to the n, its integral will be we add 1 to the exponent and divide by the new exponent. Now integral of du is equal to u minus 3 times integral of u square. We add 1 to the exponent and divide by the exponent, new exponent. Okay, 3 times u to the power of, we will add 1, 4 plus 1 and divide by 1 and minus u to the power of, we will add 1 and divide by the new exponent. The integral becomes u times 3 over 3. 3 over 3 is 1 minus u cube plus 3 over 5. 3 over 5 u to the power of 5 minus 1 over 7 u to the power of 7. And since we said that sine x is equal to u, then the integral is sine x minus sine cube x plus 3 over 5 sine to the power of 5x minus 1 over 7 sine to the 7 of x. And since the integral is an indefinite integral, we will add a constant c here, and the answer is this. And in the next video of this series, we will solve the integral of cosine cube x times sine x dx. See you in the next video.